All right, welcome back to chemistry, everybody. In this video, we're going to go over sections 2.4, 2.5, and 2.6 in our textbook, and they're all about the metric system and how we can use the metric system prefixes to convert between different units. So prefixes in the metric system are really cool because they can be placed in front of any unit to increase or decrease the size of that unit by a factor of 10. So remember in a couple videos ago we talked about different units for the metric system. So we had like grams, which measure mass. We had liters, which measure volume. We had meters, which measure length. And then we had seconds, which measure time. And these are all what's called base units in the metric system. So what a base unit is it's something that you can add a prefix to in order to change the unit, the size of the unit. So for instance, looking down here at milligrams, gram would be your base unit, right? That's our unit for measuring mass. And then milli is the prefix that you put in front of it to change how big those grams are. So, or change into smaller units. So you're still using grams to measure, but you are talking about smaller units, okay? So milligrams you might be familiar with. We use them in medicine a lot. So your vitamins or your medications might be listed in milligrams and stuff like that. Excuse me. Okay, so prefixes that increase the size of the unit are in this first table here. So let's break this down a little bit. In the first column, we have the prefix. So we have peta, tera, giga, mega, and kilo. And then we have symbols to that we can use to as a shorthand version for those prefixes. So we have capital P, capital T, capital G, capital M, and lowercase k. And I want you to make sure that you pay attention to whether it's capital or not, because you'll see down here that we also have a lowercase m. So you need to be paying attention to whether it's uppercase or lowercase, because that changes what prefix you have. All right, so let's look at the next column. So the next columns are representing the same number in different ways. So let's look at this number here. 10 to the third is the same thing as 1,000, right? We can say 10 times 10 times 10 is 1,000. So these are just represented in scientific notation on the right-hand side and numerical value on the left. But they're representing the same number. And that number is just showing hey, how much larger, right? These are the ones that increase the size of your unit. How much larger is that prefix making your unit? Or how much smaller in the case of decreasing. Okay, so your base units live somewhere right in the middle of these two tables, and they're actually in your textbook. This is one table, 2.5, on page 37. So I'll actually write that down for you. So I would encourage you to look at that and maybe even keep a tab on there. Oh, sorry, I forgot to time myself. Let me go ahead and set my timer so I know how long I'm talking to you. Okay, so your base units live somewhere in the middle of these two tables. So remember, your base units are, meters, grams, liters, seconds, etc. So anytime we're going up this way, we're getting bigger. We have bigger units than our base unit. And anytime we're going down this way, we are getting smaller. So these units are smaller than our base unit. So let's zoom out just a little bit here so you can see. So I talked about the ones that make the prefixes that make your unit bigger. Let's go ahead and talk about the ones that make it smaller. So we have, starting at the left here, we have deci, centi, milli, micro, nano, pico, and femto. And then we have our symbols, lowercase d, lowercase c, lowercase m, mu. This symbol here is actually called mu. It's a Greek letter. You might also see it abbreviated MC, and that's used in medicine. but in chemistry, we'll use the Greek letter mu. Okay, and then, oh, sorry, actually, I'll leave that there for you. Oh, and the way that you write that is you just write this little line and then kind of like a cursive U. So it almost looks like a capital M written in a really fancy way. And we will work with that one a little bit. Okay, so just like the other table, we also have these numbers here. And these are, you might sometimes see them referred to as multipliers. So you can multiply your base unit by this number or this number, remember they're the same number, in order to decrease the size of that unit. Or you could think of it as, you know, a millimeter, right? A millimeter or a milligram is 0.001. Is decreasing the base unit by 0.001. You could also think of it as dividing by 1,000, right? So, and we'll talk about how that works in a little bit. So the ones that I want you to remember for this class are just, let's put a star next to them. So I want you to remember mega, kilo, deci, centi, milli, micro, and nano. The other ones, you don't really need to know for this class. You might use them in other chemistry classes in the future or other science classes in general, but these are the ones that I want you to memorize for this class. So we'll mostly be working with kilo, milli, maybe centi. Yeah, those are the ones that we'll mostly be working with, but memorize all of these. And when I say memorize, I mean memorize like the prefix, the symbol, the multiplier. So like how much larger or smaller is it than your base unit? And then you can remember the that's called the equality or conversion factor. You'll hear me say conversion factor a lot. Okay. So a note about the equalities. And let's go to kilo first. So a note about equalities. So for anytime I'm working with metric system and trying to do conversions and stuff like that, the question I always ask myself, and it sounds kind of weird, but I always ask myself, what is my bigger, let me zoom out a little bit, unit? What is my bigger unit? And then I ask myself a second question, which is, how many small units are in one of my big unit? That's a longer question. I'm not going to write it down, but that's another thing that I ask myself. But the first thing I ask myself is, what's my bigger unit? So, and what I mean by that is, if we're comparing kilometers to meters, which one is the bigger unit, kilometers or meters? Remember, meters is a base unit. Is my base unit. Yeah, kilometers are bigger, right? And I know that because as I'm going this way on this table, I'm getting bigger and bigger and bigger. You can also think of it as I'm multiplying, I'm getting bigger by a factor of 1,000 than my base unit down here. Okay, so whichever way helps for you to think about it. And then the next question I ask myself is, how many small units, right? We already said meters are smaller than kilometers. So how many of my small units are in one of my big unit? Pause the video, try to figure out what number goes in that box there. Okay, so if you said 1,000, you would be correct. You could have also represented this number, 1,000, as 10 to the third. You could have also said 1 times 10 to the third, right? All of these are saying the same thing. They're all the same number. They're just represented differently. So see, I have this here, and then I also have this. Oops, sorry, I was trying to erase that. So I'm just going to leave it like this, though. So the idea is that it's a lot easier to work with one of your large unit and determine how many small units fit into that one big unit then to do it this way. And you could do it this way. So let's check it out. So you could do it this way where you figure out how many of your big unit fit in your one of your small unit. So what number goes here? Yeah, so the way you could have written that is you could have said 1 times 10 to the minus 3, sorry, negative 3. You could have also written that as 0.001, right? That's the same number. Or you could even write it as 1 over 1,000. These are all ways of representing the same number. I'm just going to leave it like this, because for my brain, I like it better this way. So looking at this, the reason that I say that this is the easier one to work with is because in this one, you have a fractional number here, right? This number is less than 1. So you could, if that doesn't confuse you, you can totally write your equalities or conversion factors. That's what we call these. So saying this thing is equal to this thing, that's an equality, right? You could use either one, but I do want to urge you to always ask your question, what's my bigger unit? Because I just feel like it makes things easier in the long run. And typically I find that most people do. Okay, so I'm gonna delete this here, and let's think about this concept for smaller units. So, or units that decrease the size of your base unit. So let's take a look at milli, just because we were just working with that at the top. So for milli, let's ask our question, what is my bigger, unit? All right, so let's go milligrams or grams. Which one's my bigger unit? Yeah, this time, grams. My base unit is bigger. Okay, remember, as I go up this way, I'm getting bigger, and as I go down this way, we're getting smaller. Okay, so grams are the larger unit. So let's do this. Let's think about, remember, we want to know how many small units are in one of my big unit. So 1 gram is my big unit, or grams are my big unit, and milligrams, I want to know what goes in this box. How many milligrams are in 1 gram? Pause the video, think about it. Okay, what number goes in here? Is it this number? No, it's not this number. Okay, and why isn't it that number? Well, because now I'm thinking about how many small units are in a big unit. So I like to think of it as like, here's my big unit. And here's what I'm thinking about. I want to know how many of these little tiny units fit inside my bigger unit. So this number of little tiny circles is going to be big. There's going to be a lot of them. So this number that goes here is going to be big. That's why you wouldn't have this number here. What this number 0.001 is saying over here is that you're basically dividing. You're getting that much smaller than your base unit. So you could think of it as 1 milligram is 1 over 1,000 grams, or 0.001 gram. So it's kind of looking at it from the perspective of your base unit. If that helps, the way I said that, that's great. If it confused you more, ignore what I said, right? So always, that's why I say it's easier to just think of it as how many small units are in one of my big unit. How many small units are in one of my big unit? Well, that actually is shown right here. Okay, so they show it from both perspectives. And I'll tell you what I mean by that in a second. So this number here would be 1 times 10 to the third. You could also write 1,000, right? You could also write just 10 to the third, right? 1 times anything is just that thing itself, right? So I'm just going to put 1,000 because I just find that easier to think about. So I promised that I would explain this. So you could, again, you could say, how many grams, how many big things are in one of my small thing? And then what number are you going to have here? You're going to have a fraction, 1 over 1,000, or 0.001. And that's where they're getting that number. And it's also where they're getting this number. So I hope that makes sense. If you need any help with that, let me know. But again, that's why I always recommend that you think of it from the perspective of your bigger unit. Okay. I don't want to sound like a broken record, so let's move on. Oh, let me just actually, real quick, let me highlight the ones that I like better. So thinking about what's my bigger unit, that's what I'm highlighting here. So these are the ones that I find more helpful. But again, they're saying the same thing. They're saying the same thing, just in a different way. Okay? All right, so I don't know if that helps. You can maybe take a screenshot if that helps you out. All right, let's keep moving on. This is already something I talked about, so we'll go past that. This is cool. We're not going to spend much time on it, but this is just showing you the daily values, and from the Food and Drug Administration in the U.S., we use metric prefixes to express those amounts, which is something you might be familiar with. And that's just because some of these are, you don't need as much of that nutrient in your body as others. So we only need a little bit of iodine, right? But we need more calcium. Okay, so just thinking about how we're representing numbers and how we can use units to represent numbers more efficiently, I should say. Okay, so try this learning check on your own, and then we'll check back in. So you want to put the correct prefix. So what it's asking you is 1,000 meters equals how many, or equals 1 of what? Or 1 what is 1,000 meters? Okay. All right, let's check our work. So 1,000 meters equals 1 what? 1 kilometer, or kilometer. Sorry, that should be a lowercase k. Yeah, so 1 kilometer. And you can check back on your table. You can have your textbook next to you and work on it. All right, and then this is milligram. 1 milligram is 1 times 10 to the negative 3 grams. A fractional amount, right? We've got that negative sign in front of our exponent. So you could also write this as 0.001 or even 1 over 1,000. Oh, 1,000th of a gram is 1 milligram, okay? Because milligrams are smaller than grams. All right, I hope that makes sense. And then for the next one, we have centimeters. So 0.01 meters, again, meters are larger, is 1 centimeter. Okay, let's try this last learning check. And this is the same thing. MC is the same thing as mu. So these are microliters. This is just how they use, they say micro, or they symbolize micro in medicine. So if you're going into medicine, you might see that more often. All right, let's check it out. Identify the larger unit for each of the following. Which one's bigger? Yeah, centimeters are bigger than millimeters. And you'll see that on your chart. Centimeters come before millimeters. So our centi comes before milli. Kilograms are much larger than centigrams. Milliliters are larger than microliters. And kiloliters are larger than microliters. Okay. All right, moving on to 2.5. Okay, so 2.5 is all about writing conversion factors, and you heard me say conversion factors before. So it's you could think of it as the same thing as equalities, but you'll see that we write them in a fraction form. Okay, so well, we usually write them in a fraction form. All right, let's keep going. So for equalities, equalities use 2 different units to describe the same measured amount. Okay, so remember 1,000 millimeters equals 1 meter. Something like that. That's an equality. Okay. Two different units, millimeters versus meters, to describe the same measured amount. If you have 1 meter, you have 1,000 millimeters. Okay. All right, so, and then equalities are written for relationships between units of the metric system, US units, or between metric and US units. So that's just saying you can convert between different metric units, which I've just done here, right? You can also use equalities to convert between different US units. So that's what this would be. Oh, let me, sorry, I'm having technical difficulties. Okay, so these are US units, right? The pound and the ounce. And then you can also use equalities to convert between US units and metric system. So this would be US, right? Pounds. And then this would be metric, kilograms. Anytime that you are converting between, using US units, I will give you that conversion factor or that equality, okay? So I won't, you are not expected to memorize that 1 pound is 16 ounces. You are, however, expected to memorize those ones I starred for the metric system, okay? So you need to remember those, but you don't need to remember any of the US system equalities or conversion factors. Okay, I will give you those on a test if you need them. You will need to convert between US and metric, but I'll give you these equalities. All right, oops. Okay, so conversion factors. Any equality can be written as fractions, and those are called conversion factors. Okay, so this equality that I had here, 1,000 millimeters equals 1 meter. You could also write that as a fraction. And that just means you can write 1,000 millimeters is 1 meter, or 1 meter in the numerator and 1,000 millimeters in the denominator. Okay, and we call these are both conversion factors. Conversion factors are used when you are trying to convert between different things. So here's another example of conversion factors for 60 minutes equals 1 hour. So we can write it like this, or we could write it like this. So you're just flipping the numerator and the denominator. And you can use, they mean the same thing, right? 60 minutes are always in 1 hour. There's always 60 minutes in an hour. And then same thing here, conversion factors for the metric equality, 1 meter equals 100 centimeters. You can write it like this, or you can write it like this. It's the same thing. And you'll see that we just we choose which conversion factor we want to use, this one or this one, depending on what we want our final answer to look like. And that'll make more sense in a little bit. All right, so conversion factors and sig figs. So the numbers in any equality between two metric units or two US system units are obtained by definition and are therefore exact numbers. Get back to yellow here. So in other words, this relationship, 1,000 millimeters equals 1 meter, is an exact relationship. Exactly 1,000 millimeters equals 1 meter. We've defined that as a society. It's just like 1 dozen is always equal to 12. 1 dozen anything. 1 dozen eggs is 12 eggs. 1 dozen cats is 12 cats. So that's an exact number. You wouldn't call that a measured number, and so you don't need to worry about sig figs for those kinds of things. So let's actually make a note of that. You don't need to determine, I guess, sig figs for, hold on, I don't like that S. Sig figs for exact quantities, which, or equalities. So you don't need to use sig figs. Okay, and then an equality the numbers in an equality between metric and US units contain one number obtained by measurement and count toward the sig figs. So if you have some kind of equality between metric and US, you will have something that was a measured value, and then you need to count sig figs. All right, so these are just some of the common equalities. You don't need to memorize this. I mean, you need to know the metric system. Like I said, those ones that I starred up top, but you don't need to know how to convert. Like, you don't need to memorize any of these, right? Any of these will be given to you on a test. So don't memorize those. But these are just some common ones you might need. And even the US ones, like, I mean, we know that 1 foot is 12 inches, right? But something like a yard is 3 feet. I'll remind you of that. Or a mile is 5,280 feet. We don't really know that off the top of our head. So that would be something I would give you. Okay. For things like an hour equals 60 minutes, I probably wouldn't give you that on a test because you should know that. Or a minute equals 60 seconds. That's kind of a given. So I probably wouldn't give you that on a test. But for some of these weird ones, I would. All right, let's see. Learning check. So write the equality and conversion factors for each of the following: meters and centimeters, jewelry that contains 18% gold, and this one's a little bit of a tricky one, but I would encourage you to think of mass. So how many grams of gold? And then 1 gallon of gas is $3.40. All right, so let's take a look at these. So write the equality and conversion factors. So for meters and centimeters, this one is all metric, right? So these two you can use your chart for the metric system. So 1 meter equals 100 centimeters. And notice that just by default, they used 1 meter, so they used the bigger. They said how many small things are in one of my big thing, in other words, sorry. And then they broke that up into 2 different conversion factors, right? So you have the option of putting 100 centimeters on top or on the bottom. And then, you know, the other part, 1 meter on the bottom or on the top. Okay, and you can use either of those. They're both valid conversion factors. All right, jewelry that contains 18% gold. So this is interesting. So in the jewelry, you could think of this as mass, right? And percentage is, it's a fraction. So the reason that I know that we have 18 grams of gold per every 100 grams of gold is that 100% would be 100. Right? And then 18% is 18. So if you have 18%, you have 18 out of 100, right? You could write it like this. Okay? So that's how they came up with these numbers here. And we'll go over that more in the future, but just so you know, just so you start thinking about percentages as, hey, those are just fractions, right? Percentages are fractions. So out of every 100 grams of jewelry, 18 grams of it is gold. Okay, so in my jewelry. And then 1 gallon of gas is $3.40. So this one's kind of weird, right? You have to think about it a little bit. What is the equality I can write out of just this statement? So I know I have a gallon of gas, right? So that's where they came up with this number. And then 1 gallon, per every 1 gallon of gas, I'm spending $3.40. So that's a conversion factor you could write. And you could write it either with $3.40 on top and 1 gallon on the bottom, or 1 gallon on top and $3.40 on the bottom. Okay? All right, now, last part for this video. I know it's been a long one. I'm sorry. Stick with me. We're almost done. Pause if you need to take a break. 2.6, problem solving using unit conversions. So what we find is that we can actually use these conversion factors in problems where we want to convert between units. Okay. So my general guide is to remember, I always want to analyze the problem. So what am I given in the problem? What information are they giving me? And where am I trying to get? Okay, and then how am I going to get there? How am I going to get there? Okay, so let's look at this problem together. So solving problems using unit conversion. So if a person weighs 164 pounds, what is the body mass in kilograms? All right, so for this one, this would be an example of one that I would give you the US to metric conversion factor. Okay, so let's zoom out here. I think they give it to us. Yeah, so this would not be something you would need to know off the top of your head, but you would need to know how to solve this problem with the conversion factor you're given. So let's say 1 kilogram, I'm giving you this, is 2.20 pounds. LB is how we say pounds. And so let's see, let's go back up here. So if a person weighs 164 pounds, that's what we're given. We need to get to kilograms. So now it's a matter of how do I get 2 kilograms from pounds? And to do that, you have to use this conversion factor here. Okay, so the next step is to state the equalities as conversion factors. So here's that equality, that relationship of 1 kilogram equals 2.20 pounds. So you can write it like this, or you can write it like this. Either one. And for now, write them both down until you know which one you want to actually use in your calculation. Okay, so with these problems, I always start with what I'm given. So I'm given this number here. 164 pounds. So the way that I do this, there are two ways you could set this up. You could set it up like they've done here, where you have 164 pounds. Start with what you're given, right? And then you multiply by your conversion factor. But you need to choose which one, okay? Because we want our final answer to be in kilograms. We want to get rid of those pounds and we want to convert to kilograms. So we need to cancel things out. So if I wanted to cancel out pounds, where does pounds need to go? On the bottom or on the top? Which conversion factor do I need to use if I want to cancel out those pounds? Yeah, I got to use the one where the pounds are on the bottom. Okay, so 2.20 LB, I think that looks like 16, so LB. So 2.20 LB is equal to 1 kilogram. And now, if you think about it, you can cancel out this and this, right? Because you have it in the numerator and the denominator. So you could think of it as and this isn't correct, but think of it just as like you have this over this. I mean, it technically is correct, but it just happens to be in this case. Then these two, right, you can cancel them out because they're the same thing. You're basically taking what's in the numerator and dividing by what's in the denominator. Any number divided by itself is just 1. Okay, so you're canceling out what's on the top with what's on the bottom. And then you're multiplying and dividing. So you're actually carrying out the calculation. So we got rid of those units, and now we're left with the units that we want in the top, right? We want kilograms, so we're left with kilograms in the top. Okay, so now you carry out this calculation. Let's see what that is. So we say 164 times 1 is just 164, right? And we still have our kilograms up there. Divided by 2.20, and we don't have pounds down here anymore, right? So let's not put those in there. Okay, so what's 164 divided by 2.20? That is 74.54 kilograms. It's actually 0.545. Okay, so now what we want to do is we want to make sure that our final answer has the correct number of sig figs. So in this case, the thing that was measured is the 164 pounds, right? So this person got on a scale and measured that the scale measured that they weighed 164 pounds. So we need to reflect the sig figs in that measured value. We don't need to worry about the sig figs here because why? Yeah, because that's actually an exact number. Remember we said that, where was it? Any equality between units is an exact number. Okay, so these are exact and we only need to worry about this one. So how many sig figs are in this number here? Yeah, there's 3 sig figs. Let me get rid of some of my arrows here. So how many sig figs do I need to have in my final answer? Remember, we've only been multiplying or dividing. So we're going to use the rule that we have to have the lowest number of sig figs in our final answer. Yeah, we need 3 sig figs. So we need to look over at this one. And we say we want to get to that value there because that would give me 1, 2, 3 sig figs. So we need to look next door. Is that next door neighbor lower than 5? Yes, it is. So let's leave this as 74.5 kilograms. Okay, and that would be my final answer. Okay, another way that you could write this, and it's totally up to you, they mean the exact same thing, is you can do something called the train track method. So this is the way that I learned it in school. So you set up kind of like this train track. Okay, and it's basically representing, it's representing the exact same thing, but if these fractions kind of like weird you out or you don't like them, then this is another way you could think about it. So 164 lb goes in the top. Remember, we're starting with what we're given, so the number that you're given always goes in the top left. Okay, it's what we're starting with. Oh, additionally, 164 pounds. What goes in this box here? What's like under this fraction? Or under this numerator? Yeah, there's an imaginary 1 there. Yeah, so if that helps you, you can put a 1 there. If you don't like to see it blank, that's okay. You can put that 1 there. I'm going to leave it for now. All right, so 164 pounds goes on the top again. Now for our next train track. So these are the train tracks. What goes in that next train track? Yeah, it's going to be the same thing. We're going to have 1 kilogram on top because remember, whatever goes on top is what we're going to end up with, right? We want to cancel out those pounds and end up in kilograms. And what goes in the bottom is still that 2.20 lb. Pounds, sorry. Whoops. I'm just trying to shorten my train track there. All right, and this is the same thing, just represented in different ways. All right, so again, we can cancel out those pounds. We have pounds in the numerator and in the denominator, so we can cancel those out, excuse me. And then we carry out the calculation just like we did before, and we're going to get 164 kilograms over 2.20. Remember, we got rid of those pounds. Okay, so then we get, again, 74.5 kilograms. Just the same exact thing, just represented in a different way. So each one of these train tracks is a fraction, just like you have here. Whatever works for you, okay? I honestly will I'll probably switch back and forth between the two of them. But if there's one that you guys prefer as a class, I'll ask you about it and I can try to represent it that way instead. Okay? All right. Well, that's all I wanted to show you for these 2 videos. We will practice this unit conversion thing. And I'll see you again in the next video.